All right. What is heteroscedasticity, or what we call the situation of unequal variance of the disturbance term? So anyway, we have this classical linear regression model assumptions, that is, mean value is zero, the variance is constant, no relationship between the two independent variables, and also like no relationship or no correlation between the two successive disturbance terms. And of course, also one we have the problem of endogeneity that we have in panel data, that is no relationship between the disturbance term or any of the independent variables. These are, well, of course, these are different issues that we face in running a regression. So what basically heteroscedasticity means is like the variance of the disturbance terms should be constant. But in many cases, when we are generally dealing with a cross-section data, we do not find the value of the variance to be not constant, or it is not equal to sigma u square, right? So that's why, when it is not equal to sigma u square, which is a constant, then we have the problem of heteroscedasticity. All right. So it is something like, as per classical linear regression model assumptions, your variance should be equal to sigma u square. That situation or the condition, we call it homoscedasticity. But when the variance is not equal to sigma u square, the situation is called as the condition of heteroscedasticity. Anyway, uh, mostly this problem of heteroscedasticity arises in case of when we are dealing with the cross-section data. That means when we are dealing with the household samples data, or the data sets which are collected or which are in the form of samples. So it should be very much kept in mind, like that samples, or the samples that we have collected, should be very much homogeneous. In fact, it should be like having the same characteristics, not so much variability in those data sets. So it is like those data sets should be homogeneous. But if in case, if you are talking about, if you take some variables, include some variables, like, and you try to make the data sets, your whole data sets, into heterogeneous or heterogeneity, then the problem of heteroscedasticity actually arises. So it's a simple example. Suppose like we are talking about saving patterns of the rural, saving patterns of the household. So you cannot simply like club up, you cannot simply like club up the saving pattern, or you take the samples from the rural village households, and also take the urban households from the urban areas. So it is like, simply you can just imagine, like, right, that savings of the rural villagers or the households will be much smaller, or like rural villagers will have a different characteristics of savings behavior. But if you go to the urban households, they might have a different, they might be having more than what the rural villagers are actually saving there. So it becomes like a kind of heterogeneity, or it comes like a non-homogeneous. So if you're talking about rural, then please talk about only about rural areas. And then if you're talking about urban areas, then separately we can talk about urban areas. But if you try to club them up, if you try to club them up or take them together, that might be the problem of heterogeneity in your data sets. So now if you try to estimate this equation despite being aware of the heterogeneity, then we find that the estimators will no longer follow the blue property. So in regression, our estimators should be following the blue property. Otherwise, our estimators are like not not means interpretable, or it is not the correct estimate of the parameters. So anyway, but what we get, even if we estimate in the presence of heteroscedasticity, is like we get the estimators to be still linear and unbiased. That means it is still linear and it is still unbiased, like it is still comparable with the sample parameter and the population parameter, or there won't be much difference when you talk about this unbiasedness. Well, of course, linearity, it is like, yeah, it is not having any power attached, or like it is a linear, uh, I mean the linear estimate, I mean the linear regression analysis, you can say, like. And then, but the problem, the major problem that we find is that the minimum variance, or the best that we have in a blue property, the minimum or the variance will not be the least, or it will not be the minimum. In fact, it will be much larger, right? It will be much larger when you try to estimate the parameters in the presence of heteroscedasticity. Well, I will upload one video about what are the consequences of estimating parameters in the presence of heteroscedasticity. But well, for now you just understand the summary of what is the heteroscedasticity like. Simply you can say like it is the non-equal variance or unequal variance, and then you can say like you should remember it something like it normally occurs in case of heterogeneity of the data, or your data sets should are not homogeneous, and then like your blue property is violated. That means they are still linear and unbiased, but the mean variance is not the least, or we do not have the minimum variance. Well guys, that's all for today now. Thank you again.